Okay, good morning class. So we have now the sample problem given in your notes 3. So that is to adjust the latitude and departure using compass rule or using transit rule. But in this problem, we'll just use compass rule. For transit rule, that is your assignment. I will just give you another set of problem to solve using transit rule adjustment. Okay, so for this problem, you are given in the accompanying tabulation the observed data for a traverse obtained from a closed survey. So you determine the latitudes and departure of each course and its adjusted value by employing compass rule. Also determine the linear error of closure, the bearing of the side error, and the precision of the survey made, or that is the relative precision. But before we continue, let's have first the formulas for compass and transit rule. So for the compass rule, you have this formula. Small letter CL is equal to big letter CL multiplied by the distance of any course or distance of the specified line, or for example that is distance of line AB, divided by the total distance, or big letter D, the total distance or total length of the traverse or the perimeter of the traverse. Okay, and for the correction to be applied for the departure, that is CD, small letter CD is equal to big letter CD multiplied by small letter d divided by big letter d, where your small letter CL and CD, that is the correction to be applied to the latitude and departure of any course, and then big letter C, L, and CD, that is the closure in latitudes and closure in departure. This is departure. Okay, or CL, that is the algebraic sum of the north and south latitudes, and then CD is the algebraic sum of the east and west departure. Then small letter D, that is the length of any course, for example length of line AB, and then D is the total length or the perimeter of the traverse. Okay, so that is the formula for the compass rule. For the transit rule, you have this formula. So if you use transit rule for your assignment, you have to use this formula. Small letter CL is equal to the latitude of any course or latitude of that line multiplied by the total closure in latitude divided by the summation of all latitude in the traverse. And then for the correction for departure, this is equivalent to the departure multiplied by the closure and departure divided by the total or the arithmetic sum of all the departures. Okay, so that is the formula for the transit rule. And then for the formula for the linear error of closure, by the way, the linear error of closure is usually a short line of unknown length and direction connecting the initial or the first line and the last line of station of the traverse. This is your LAC. So when you plot the technical description of the lot, usually it doesn't have the common point. Usually you have this distance that is called the LEC. So to compute for the LEC, you have this formula that is LEC, or the linear error of closure, is equivalent to the square root of the total closure in latitude squared plus the total closure in departure squared. So that is just the Pythagorean theorem. Since you have the total closure in latitude and then the total closure in departure. And then to solve for the bearing or the angle, that is tangent inverse of the closure in departure divided by the total closure in latitude. So the angle here is this one. So usually the angle starts from the reference meridian. Okay? So that is the formulas for the LEC and the angle theta. Okay? Or angle beta. And then to solve for the relative precision, you have this formula. So the formula is relative precision is equal to 1. So the numerator is always 1 divided by the total distance or the perimeter of the traverse divided by the linear error of closure. Okay? And then if you have now the adjusted latitude and departure, you can have the adjusted length and directions of each lines. So when you have the adjusted, that is prime, or the latitude prime, and the departure prime, that is the adjusted latitude and departure of each lines. So the formula for the adjusted length, you have the square root of adjusted latitude squared plus the square root or plus the adjusted departure squared. And to solve for the angle alpha or any angle for your lines, that is tangent alpha is equivalent to the adjusted departure divided by the adjusted latitude. Okay, that is on how to solve the adjusted length. So if you have the adjusted latitude and departure, you can directly solve for the adjusted length and the angle theta or angle of your lines. Okay, so let's now have the problem. Given is you have course AB, BC, CD, EF, DE, EF, and FA. That is a closed traverse. And then you are given a distance and a bearing. So usually you have these lines. Okay. For example, this one. You have line AB. So for this line, this is your latitude. And for this line, this is your departure. And then you have your bearing. Usually from the reference meridian, if bearing is not given, sometimes the given is azimuth. Okay, so bearing and azimuth are usually the same for the sign conventions. Okay, so for the formulas, you are to solve for the LEC. CL squared then the bearing tangent inverse of CD over, and then relative precision 1 over D over LEC. Okay, so first we'll solve for the latitude and departure of each lines. So we can have the formula length times latitude is equal to length times the cosine of bearing to solve for latitude. And then for the departure, we can have length times the sine of the bearing or the angle. Or let's check using the rectangular function of the calculator. Okay, so let's have line AB, rec 495. So for the function, you have rec, then distance, angle. Okay, 0.85 comma then 5 degrees 30 minutes. So you have 495 493 0.57 and 47.53. Okay, next line is 850.62. Angle is 46 degrees 2 minutes. 590.53 and then 612.23. Next line is 855.45 comma 67 degrees 38 minutes. So that is 325.53 791.09. The next is 1020.87 12 degrees 25 minutes 996.99 and then 219.51. Okay, Then next line is 1117.26, and then 83 degrees 44 minutes. So that is 121.96, 1110.58. Then last line, you have 660.08. Angle is 55 degrees 9 minutes. So you have 377.19 and 541.70. Okay. By the way, we have the sign convention for north, that is positive, south, that is negative, for east, that is positive, for west, that is negative. Okay, so that is north, so positive. North, positive. South, negative. Negative, south, negative. North, positive. That is for the latitude. And then for departure, you have east, positive, east, east. So positive, positive, positive. Then west and west, negative, negative. And then you have to solve for the CL and CD. Okay? To solve for CD or CL, you just have to add or arithmetic sum with the following sign conventions. Okay? So let's add positive 493.57. By the way, let's check first our answers using the formulas length times cosine or sine of the angle. So for the latitude, 493.57, 590.53, 325.53, 996.99, 121.96, then 377.19. And then for the departure, you have 47.53, 612.23, 791.09, then 219.51, 1110.58, and 541.70. So just the same answers for the solution with cosine and sine and the rectangular function. Okay, sometimes you have to tabulate the data like this, or you can have just like this tabulation. Okay, it's up to you. You have to group the north latitude and south, then group the east departure and west departure, or you can have this tabulation. So let's calculate now the closure in latitude and closure in departure. Okay, so for the latitude, that is 493. Point 47 plus 590.53, then minus 325.53, minus 996.99, minus 121.96, and then plus 377.19. So that is positive 16.81. And then for the departure, you have positive 47.53 plus 612.23 plus 791.09 plus 219.51 minus 1110.58 minus 541.7. So that is positive 18.08. So meaning the north, this one for the north latitude is bigger than the south latitude, since your answer is positive. And also for the departure, that is positive, so therefore your east departure is bigger than your west departure. Okay, so you need to have that numbers so that you can now decide where your correction is to be added or to be subtracted. Okay, so if your north latitude is bigger than your south latitude, the correction of north latitude, since that is bigger, so minus, and the south latitude, which is smaller, so add or plus the correction. And then if vice versa, the south latitude is bigger than your north latitude, so therefore your south latitude is minus the correction, since smaller is your north latitude, so add or plus the correction. Okay, next is to solve the distance D, or the perimeter, or the total length of the traverse. Okay, so you add all the distances: 495.85 plus 850.62 plus 855.45 plus 1020.87 plus 1117.26 and plus 660.08. So that is 5,000.13 meters. So if you have these values, you can now solve for the LEC. Okay, so to solve for the LEC, this one, so to solve for the LEC using these values, you can have square root of 16.81 squared plus 18.808 squared. So you have your linear error of closure equal to 24.69 meters. And then for the bearing or the angle beta, that is tangent of CD, which is 18.08 over 16.81. So to convert this number to angle form or degree form, just press the degree, minutes, and seconds in your calculator. So that's automatically convert it into degrees. So that is 47 degrees 5 minutes. So for this line that is positive and positive, so normally this is the last point. Maybe this is F, and positive, so quadrant 1, this is your um, this is your A. So you have your CD and CL. So therefore your angle is this one, beta. So your direction of your bearing is southwest. Okay? So that is how you solve for the direction of the bearing. And then next you have for the relative precision, you have this formula. So 1 over D, that is 5,000.13 divided by 24.69. So just operate the denominator. So the numerator is always 1. So therefore, you have 5,000.13 divided by 24.69. Okay, so that's equivalent to 202.52, or just make it rounded off to hundreds, that is 1 over 200. That is the answer for the relative precision. So maybe let's try to check it with the calculation in the book. So to continue with the solution in the book, you have here the tabulations of northings and southings. So north latitude and south latitude, and then the east departure and west departure. So you have the summation of all the north latitude and the south latitude. So upon investigation, upon seeing the values, you have the bigger value is the north latitude. So therefore, so since the north latitude is the bigger value, so the correction for the north latitude is to be subtracted. And then the correction of the south latitude is to be added to the south latitudes. Okay, next is the departure, east and west departure. So from the data, the values, the east departure is bigger than the west departure. So therefore, the correction of each departure is to be subtracted to the departures, and then for the west departure, the correction is to be added. Okay, so to solve for the correction closure, total closure of latitude, it is 16. So you have the summation of north latitude and south latitude. And then for the departure, you have east departure and west departure. So the same answers with when you have these tabulations. Okay. Next is to solve for D, which is we already solved that. That is 5013. So let's check if it's the same. So you have 5013. Next is to determine the correction for latitude. Normally, I will not use this formula, since if you use this formula, you have this answer is already rounded off. So I will use the normal formula for this. Small CL is equal to big CL times small d over big D. That is for latitude. For departure, that is small CD is equal to big CD times D over D. Okay? So normally, I will not use this formula since it already rounded off the value for K. So when you solve for these values, maybe you can round it up or round it down because of these values. So in my case, I will use, and maybe I will be using this formula even in your exams. Okay, these formulas. Okay, so let's try to check if using this formula, when you use this formula and this formula, we will check if it's the same answer. Okay, so first you have to recompute this one. If that is 0.00336, 16.81 divided by 5000.13, so that is 0.0036. Okay, that's correct. So we'll compare these calculations with our answers to this calculation, or to this formula. Okay, so let's have that 16.81 over 5000.13 multiplied by 495.85. So that is 1.67. Okay, correct. Next is 850.62. So correct. Same answers. And then 855.45. 2.88. Okay, correct. Then line CD 1020.87. So correct. And then next is 1117.26. That is 3.76. Okay, so I will explain later why it became only 3.75. So next, last line is 660.08. So that is correct. So when you add these values, let's add these values, 1.67 plus 2.686 plus 2.88 plus 3.43 plus 3.75 plus 3.76 plus 2.22. Okay, so your answer is 16.82, and our correction is only 16.81. So normally in this case we are in excess of 0.01. Okay, so in this case, if ever you have an excess number of correction, so if excess, you are to subtract the excess number to the bigger value in the correction. So the bigger value here in our correction is 3.76, and then our excess is 0.01. So therefore 3.76 minus 0.01, so you have 3.75. That is if ever you have an excess number of correction. But if you have a lacking number of correction, you have in short number of correction, so you add the lacking number to the smaller values or the smallest value. Okay, so if ever you have your answer to 16.80, you are lacking of 0.01. So therefore, your 0.01 is to be added to the smallest value in your correction. Okay? Okay, since in our case that is bigger value, so therefore, instead of 3.76, now we have this as 3.75. So that we'll have this total correction equal to 16.81. Okay, it should be equal to our correction or the closure in latitude, and also for the closure in departure. So let's check with our calculation, closure in departure. Okay, so you have 18.08 divided by 5,000.13 multiplied by 495.85. Okay, so this is correct, 1.79. Next is 850.62, 3.08. Okay, correct. Next is 855.45, correct. Next is 1020.7, so this is correct. And then 1117.26, 4.04. Then last line, that is 660.08, 2.39. Okay, then you add that 1.79 plus 3.08 plus 3.09 plus 3.69 plus 4.04 plus 2.39. So it should be equal to 18.08. Okay, so the corrections in each line is equal to the total closure in departure. Okay, so to adjust the latitude and departure, so you have the formula. Computed latitude, you have the first computation plus or minus the correction. But in our case, the north latitude is bigger than this south latitude. So therefore, the correction for the north is minus or subtract. The correction for the south latitude is to be added or plus. Okay? So for this sign convention, this is north, north, south, 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 north. So no need to add this sign convention. You have the close parenthesis to solve for the adjusted latitudes. Okay? So for the adjusted latitude, you have the computed minus the correction since that is north. And also, the computed latitude for line BC. And then the computed correction, so minus, since that is north. And then for this one, south, so add. This is the correction. And then for latitude or line DE, this is the correction. And you have the computed latitude. So this is south, so plus or add. And then for this one, that is line EF. Line EF, that is south, so add. Then you have for line FA, that is north, so minus. So if you add these numbers, it should be equal to 0. Okay? So let's try to add this. Positive 491.90 plus 587.67 minus 328.41 minus 1000.42 minus 125.71 plus 374.97. So it should be equal to 0. If that is not equal to 0, so maybe your correction is wrong. Okay, it should be equal to 0. So you have the note as what I have said. If the sum of the north latitude exceeds the sum of the south latitude, corrections are subtracted from the corresponding north latitude since the north latitude is bigger, and added to the correction a corresponding south latitude to determine the adjusted latitude. Okay? So mas bigger value for the north latitude, so subtract. And smaller value for the south latitude, so add the correction. Okay, so when you add all the latitudes, it should be equal to 0. Next, let's have the adjusted departure. So for the formula, adjusted departure is equal to computed departure plus or minus the correction in departure. So since this is departure, so if that is east, so minus. If west, plus. Since the east departure is bigger value than our west departure. Okay, so you have here the correction. By the way, this is east, 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 west. So therefore, for the correction, since that is east, so minus. Okay. Next correction for line BC. BC. You have the correction that is east, so minus. And then next line CD, the correction that is east, so minus. And then DE, 3.69, this one. And then that is east, so minus. This is not for the sign convention. This is for the correction. If ever, whichever is the bigger, that is minus the correction. If that is the smaller value, add or plus the correction. Then for line EF, that is west, so plus. And lastly, line FE, it is 2.39, this west, so plus. So you have your adjusted departure. So if you add this, that is equivalent to 0. Okay, 45.74 plus 609.15 plus 788 plus 215.82 minus 1114.62 minus 544.09. It should be equal to 0. So note, since the sum of the east departure exceeds the sum of the west departure, the departure correction are subtracted from the corresponding east departure and added to the corresponding west departure. Okay? So when you add these values, it should be equal to 0. And then you tabulate the data for adjusted latitude, south and north, and then adjusted departure for east and west. The closure in latitude and departure should be equal to 0. Okay, so to check, to solve for the linear error of closure, we have this value 24.69. We already solved that. Okay, so this one, 24.69. And then for the angle beta, you have this formula. Beta is equal to tangent inverse of CD over CL. Okay, so you have your answer equal to 47 degrees 5 minutes. And then for the bearing, that is southwest. Okay, and then for relative precision, you have this formula 1 over D over LEC. So the answer is 1 over 202.52, or you can have rounded off to the nearest hundreds, that is 1 over 200. And then for this problem 2, you are to solve for the adjusted length. So you already have your adjusted latitude and departure. So now let's go back to the lengths and the bearing or the angles. So you already have your adjusted latitude and departure, so you can solve for the adjusted length. So from the formula, you have the adjusted length is equal to the square root of adjusted departure squared plus the adjusted latitude squared. Okay, so you have this computation. Okay, so refer to the tabulation for the adjusted latitude and departure, and also for the bearing. So for the bearing, you have this formula, tangent of alpha of line AB is equal to the adjusted departure, this one, over the adjusted latitude. Or you can have the formula using your calculator, the polar function is equal to latitude and departure. Okay, so let's have an example. So shift polar. So in my case, that is shift plus, and then the latitude, type the latitude. Latitude is 491.90, then comma, so that is shift close parenthesis. And then type the departure, 45.74. Okay, so you have your answer. 494.02, and then the angle is 5 degrees 19, but in our case 5 degrees 31, 5.31. So to convert 5.31 to degree form, so you just type 5.31 and then press the degree, minutes, and seconds. So that's automatically convert your value to degree form or the angular form. Okay, so that is 5 degrees 18 minutes 36 seconds. So you can round it up to 5 degrees 19 minutes. For the direction, you have already this in the given values of direction for the bearing. Okay, so let's have another example. Shift pole, let's have this example. So negative 125.71 shift comma negative 1114.62. Okay, so you have your answer. This one, 1121.69, and then for the angle is 96. So 96, that is negative, so that is the complementary angle or the other side of the triangle, no? So if that is negative, so for example this is the triangle, instead of this is your angle beta, and that is negative, this is the given angle. So in that case, that is 96 sa 96.43. In angle, that is 96.25, or that is 96.26. So this is 90. So for this angle beta, that is 180 minus 90 minus 96 degrees 26. It should be equal to, let's have this calculation, 180 minus 90 minus 96 degrees 26. I know. $180. No, it's not 180. It's the other side. Okay? So 180 degrees minus 96 degrees 26. That is 83 degrees 34 minutes. Okay, so that is the complementary angle. Okay, then after that, if you already solve all the adjusted length and adjusted bearing, you tabulate your answer with the adjusted latitude and departure. Okay, so that is the answer to the problem. Thank you.